Look up at the sky, gaze into the vast expanse above where clouds gather and mysteries unfold. For millennia, humanity has watched lightning split the heavens, a spectacle of immense power and untamed energy. A raw, mysterious force that has both terrified and inspired awe in equal measure. Ancient cultures spun myths, trying to explain the unexplainable. Thor's hammer, a symbol of divine might, Zeus's thunderbolts, weapons of the king of the gods, but behind the stories, behind the legends was a real phenomenon, a tangible force at play. Electricity, the very essence of energy unleashed. It was untamed, a force of nature beyond human control, terrifying and utterly captivating, drawing the eye and sparking the imagination. The journey to understand this force began not with thunder, not with the grand spectacle of lightning, but with a spark of curiosity, a quiet observation that hinted at a deeper truth. Before power plants or light bulbs, before the conveniences of the modern world, we had to recognize electricity in the world around us, to see its subtle manifestations in the natural world. That same power in the sky, that dramatic display of electrical energy, could be found in the smallest things, in the most unassuming of places. Like a spark of static on a dry day, a tiny jolt that reveals a hidden connection. The story of electricity, from its mythical origins to its scientific understanding, is humanity's quest to pull back the curtain on one of nature's greatest secrets, to unravel the mysteries of this fundamental force. It's a detective story that started thousands of years ago, a journey of observation, experimentation, and discovery. Not with a bang, not with the roar of thunder, but with a whisper, a subtle hint of what was to come. Our first clue? A simple, ancient observation, a moment of quiet contemplation that would change the course of history. The journey begins, a quest to understand the power that shapes our world. Let's embark on a journey, traveling back in time to ancient Greece, the cradle of Western civilization. Our destination is the bustling city of Miletus, a prominent center of trade and intellectual thought around 600 BC. Here lived Thales, a philosopher, mathematician, and a keen observer of the natural world, a man driven by curiosity. It was Thales who first noticed something peculiar, something strange and captivating about amber, or what the Greeks called electron. Through simple experimentation, he discovered that when rubbed vigorously with fur, amber possessed the uncanny ability to attract light objects like feathers and straw. This intriguing phenomenon wasn't attributed to magic or myth, as many natural events were in those times. Instead, Thales recognized it as a real, repeatable effect, a demonstration of what we now know as static electricity. Of course, Thales didn't possess the modern understanding of electrons and atomic structure, but he meticulously observed cause and effect, laying the groundwork for future scientific inquiry. Through careful documentation, he recorded what is considered the first human-made observation of an electrical phenomenon. This seemingly simple act, rubbing amber, might appear insignificant at first glance, but it represented a monumental leap in human understanding, a transition from relying on myth to embracing the power of scientific observation. Thales's groundbreaking observation planted the seed for everything that was to come in the realm of electrical science. While he didn't possess the means to harness electricity for practical applications, he was the first to identify it as a distinct and observable force of nature, setting the stage for future exploration. It's worth noting that the Greeks themselves gave us the very word, electricity. The term was directly inspired by amber's mysterious and captivating power to attract. So, if we were to pose the question, which country can lay claim to having discovered electricity? The earliest and perhaps most accurate answer is undoubtedly Greece. But this initial spark of discovery was just the beginning of a much grander narrative. The seed of electrical understanding once planted would lie dormant, awaiting the right conditions to germinate and flourish in the centuries to come. For centuries, electricity was a curiosity, an amber trick, a myth, a mystery. Yet hints of its power surfaced elsewhere. In ancient Mesopotamia, the Baghdad battery may have produced electric currents, perhaps for electroplating. In Egypt, electric catfish were used for healing shocks, a primitive electrotherapy. These were applications, not scientific breakthroughs. The knowledge wasn't passed down or built upon. The true scientific revival of electricity had to wait. It would take a new age of curiosity, a renaissance of thought. The world needed a new kind of investigator. The next chapter would begin in England. The spark was about to be reignited. The year is 1600. In England, a pivotal figure named William Gilbert, a physician to Queen Elizabeth I, reignited the study of electricity. He embarked on a series of experiments, meticulously investigating electrical phenomena. He discovered that many materials, not just amber, could be electrified by rubbing, a process we now understand as the triboelectric effect. Gilbert, recognizing the significance of his findings, coined the term electricus, directly derived from the Latin word for amber, giving us the word electricity. This was a monumental step in defining and categorizing this mysterious force. He distinguished electricity from magnetism, recognizing them as separate though related phenomena, effectively founding a new science dedicated to understanding these forces of nature. Across Europe, inspired by Gilbert's work, scientists and inventors began to build more sophisticated machines to generate static electricity, pushing the boundaries of what was known. But the biggest leap, a truly groundbreaking revelation, came from across the Atlantic, from America. Benjamin Franklin. Franklin, a man of insatiable curiosity, asked a profound question. Is lightning, this awe-inspiring display of natural power, the same as the static electricity we create in our labs? His famous, and rather dangerous kite experiment, conducted during a thunderstorm, definitively proved it was. This discovery unified a cosmic force previously seen as divine and untouchable, with the everyday sparks observed in laboratories. Franklin's groundbreaking work directly led to the invention of the lightning rod, a simple yet ingenious device that has been instrumental in saving countless lives and protecting property from the destructive power of lightning. Meanwhile, across the ocean in Italy, scientists were embarking on their own unique investigations exploring the intriguing concept of animal electricity. The key figures in this debate were Luigi Galvani and Alessandro Volta, who engaged in a spirited debate about the true source of this mysterious animal electricity. Volta's eventual answer, born from rigorous experimentation and insightful analysis, would ultimately change the world and usher in a new era of electrical innovation. Volta set out to prove electricity came from metals, not animals. He invented the voltaic pile, the world's first true battery. For the first time, electricity could flow steadily, powering experiments and discoveries. Volta's battery, born in Italy, launched the electrical age. So, which country discovered electricity? Greece gave us the first observation. England systematized its study. America connected it to the cosmos. Italy gave us the power to control it. The story of electricity is a global journey, built on curiosity, observation, and invention. And it's still unfolding every time we flip a switch.